In this tutorial, we will see how to use RapidMiner Studio to build a prediction model using multiple linear regression when all the variables are quantitative. And the assumption is that you are familiar with the conceptual foundations of multiple regression, so the emphasis will be on using the software to build, train, and evaluate the model. So we will estimate the model parameters using training data and then interpret those model parameters and the diagnostics that are generated as part of the training process. And once the model is trained, we will use the trained model and evaluate its performance using validation data and different types of metrics. So the data set that we plan to use for this model building exercise is a used car data set from India. And we have extracted 5 quantitative variables for our use. The first one is the mileage of the car reported in kilometers since it's from India, the fuel efficiency in kilometers per liter, followed by engine capacity in cubic centimeters, and then the power in brake horsepower, and finally the dependent variable price in local currency appropriately scaled. And the regression equation that we're trying to estimate is the second one that you see in the slide. So we are trying to predict price as a function of kilometers, kilometers per liter, engine capacity, and power. So we are trying to estimate the parameters B0, B1, B2, B3, and B4. So let's start up RapidMiner and begin our model building process. So this is the standard RapidMiner user interface that you're familiar with by now. So I'll go to the repository panel and I'll first double click on the dataset icon just so you get a feel for the data that you're working with. You already know the 5 variables that are in play in this model building exercise. But you can see that there are 5,874 observations or rows, and we will partition this data set into a training subset and a validation subset, and we will use that for performance measurement. So that's the context, the setting in which we are beginning our model building, model development process. So let me click on the design tab over here and begin the process. So you'll recall that in RapidMiner, we build processes and then we run them, and processes are sequences of operators chained together. So the first operator that I drag into the process box is the operator that will fetch the raw data for me. It will retrieve the regression raw data, those 5,874 observations. Okay. Now, following that, the first operation I want to do after that is to tell RapidMiner which of those variables will be my dependent variable. And I do that using the set role operator. So I pick up set role from the operator panel, I drag it in, and I connect the output port of the retrieve operator to the input port of set role. So I'm getting the ball rolling in terms of developing this process. So now I click on set role and I customize this operator. So I move over to the parameter panel. All the information that you see in the parameter panel and the help panel are context sensitive. They are tailored to the particular operator that I've highlighted now. So I'm going to tell RapidMiner here that among all the 5 attributes, I pick price. So I've highlighted price, and I tell RapidMiner that I want it to be the dependent variable by saying that it's the label. That's the term that RapidMiner uses to identify a variable as being the dependent variable. So I've finished telling the software that which one of those 5 variables is my dependent variable. Now, in the next step, I want to tell RapidMiner to split the data set into a validation and training data set. Now, I know which one is the training subset and which one is the validation subset. All I have to tell the software is to split the data set into 2 subsets. Okay. And again, this is an operation you have seen in an earlier video that I have on data preparation. So I won't dwell too much in depth, but the operator is split data. You can go to the previous that earlier tutorial and see further details about this preparation, but the operator is split data. I pick it up and I drag it into the process box. So I chain it again, connect the output port of set role to the input port of split data. And now I highlight split data and I move over to the parameter panel. And in the parameter panel, the partitions, here's where I'm about to define my partitions. So I click on the partitions button, and I add an entry where I tell, and I put in 0.7. I could put any fraction in there, but I'm telling RapidMiner that 70% of the data will be my first partition. So out of those 5,874 records, 70% of them should be reserved in the first subset or the first partition. I click add entry again, and I pick up 30% as the second partition. So I'm done telling RapidMiner that how to create the two partitions. And again, the second box over here, which says how should I pick those subsets, I will pick shuffle sampling. So if you recall from that earlier tutorial, shuffle sampling will make sure that the records are put into these two subsets randomly. So they're chosen at random from the entire subset that we have, entire data set that we have. The two subsets are generated, the records are picked at random to be put into the two subsets. Okay, so let me move these operators around just to make a little space for myself visually. So I've got the three operators here. So next I will bring in the star of the show, so to speak, the linear regression operator. So here's the linear regression operator. I drag it out from the operator panel and drop it into the process dialog box. And you can see RapidMiner is saying, where shall I find the training data to train this linear regression model? You can see the input port in red with the letters TRA asking for the training data. So here's the first partition. So RapidMiner has made the first partition available to us. Remember, we split the data into two subsets, two partitions. So the first partition is available, that has 70% of the records. So I just connect that first partition to linear regression. And you can see that the red alarm mark in the input port has gone away. So linear regression is satisfied that it's got its training data to do its training. Okay, and once trained, the trained model will come out of this output port which says mod. Okay, now before we proceed any further, I need to customize the linear regression operator, because if you move over, it's a fairly complex operator, and if you move over to the parameter panel, there are all kinds of options that you can set. I will just highlight the most important ones that you should pay attention to. So you can see it's in the feature selection, RapidMiner has this default which says M5 prime. You didn't bother yourself with what that algorithm is. Basically what RapidMiner is saying is, I have my own method of selecting the independent variable. So I have given 4 independent variables here, but it said, maybe you don't need all 4. I will pick the ones that I want on my own, that should be used on my own. Now, since we are learning this method, I do not want RapidMiner to do any thinking for me. So at least for this course, please be absolutely sure to take this to click none. So I do not want RapidMiner to do any kind of automatic selection on my own. I will do those selections once I have learned the methods. Okay, and also this box which says eliminate collinear features, just uncheck it. So basically the entire output will be made available to you for your inspection, review, and you get to choose what stays and what goes. You don't want the software to be doing any automatic thinking for you, at least not now, before you become an expert in the technique. Okay, so the linear regression operator has been set up the way we want it. And now before I can evaluate how well it has been trained, I need to make some predictions. So only when I compare predicted values with actual values will I know how well the model has been trained. So to make my predictions using the trained model, the operator that I need to use is called apply model. So I hunted for it in the operator panel, and by typing in the words apply model, and here is the apply model operator, I drag it and drop it into the process box. And you can see the input ports that are currently showing in red. It's asking for 2 inputs. One is, where is the trained model? So you can see MOD, it's asking for the trained model. So let me give it the train model. So I connected the output of the regression model to the input here. So I have provided the train model, and you can see the red alarm or the warning color has gone away from that input port because it's gotten the input that it needs. The next input that it needs is the validation data on which to apply the trained model. So interestingly, do you see that as soon as the first partition got used up for training, the second partition has been made available to us by RapidMiner in the model building process. So here's the second partition. This is the partition that has 30% of the records. And I will just connect this to the second input port of apply model. Now, the predicted values and the actual values will be turned out by the apply model operator from this output port, which is labels. Okay, and this is what we will feed into another operator that will actually calculate the performance metrics for us. So the operator that will actually calculate the performance metrics for us is called performance. Okay, and there are many different performance metrics that one can use. You can see over here, I just typed in performance, and there are performance metrics for classification algorithms. There are performance metrics for binary classification. In our case, we want performance metrics that are specific to regression. So I picked up performance regression, and I plopped it down here into the process dialog box, the process modeling box. So look at the inputs that it wants. It's the performance metric, the performance operator is saying where are the predicted and actual values that I will use to judge performance. So in order to provide that input that it needs, which is in red, you can see it's a warning to you that the operator doesn't have the inputs that it needs. So I connect labels from apply model to labels for performance. So the apply model operator has generated the predicted and it has the actual values. Those two are fed into the performance operator, which will now do its performance calculations. So let me click on performance, and obviously now I have to choose, I have to customize. On the right hand side, you can see in the parameter panel, there are all kinds of performance metrics that one can use. So we will pick a few of them. You can look at the help panel at the bottom over here to get further information on what these different performance metrics are. And you can choose the one that's most appropriate for your needs. So a very common performance metric that's used is root mean squared error, RMSE. So let's take it piece by piece. So the error is the difference between actual and predicted values. Sometimes the error will be positive, sometimes it will be negative. Hence, we square it to eliminate the negative sign. And then we take the average of those squared errors and then take the square root to undo the squaring, so to speak. So it's the RMSE, root mean squared error. Of course, you can pick also the absolute error, which absolute error is simply the absolute value, absolute difference between the predicted and actual value. And the absolute error will give you the average of all of that for each of the data points. Okay. Now, in addition to these two metrics, I will pick up two more. One called correlation and the other called squared correlation. Particularly that last one, the squared correlation, is the well-known R squared value that you're familiar with from your fundamentals of regression. So I've just included the performance metrics. Okay, so the performance metrics, the four that I have just identified in the parameter panel over here, these will be generated by the performance operator, and those performance metrics will be generated, will be put out from this output port which says PER, performance. Okay, and to actually see these performance metrics, I simply connect that output port, the results port, to actually view the output. Now, I want the performance metrics, but I want to see a few more things in my output as well. So this second port that you see, which says examples, I'm going to connect this to another results port. And what that will do is RapidMiner will show me the actual and the predicted values of the dependent variable. It will actually show me the values. In addition to the performance metrics that we saw from the previous port, output port, we will actually see the predicted and actual values of the dependent variable. We can take a look at them. And what I also want to do is to see the model itself. What is the fitted model? What is the, once the model has been trained, what does the model look like? Remember, we started off saying that we are trying to estimate coefficients B0, B1, B2, B3, and B4. What are those coefficients and how do we interpret those? So I connect the model to another output port, results port rather, and now we are all set. So the process has been set up, and now we are ready to run this process. So the heart of this process is the linear regression model, but we have ancillary operators to first retrieve the raw data, to split the raw data into training and validation sets, and then some other operators to judge performance. But the star of the show is this linear regression operator, the model itself. And the other operators around it are there for training, validation, and setup. Okay, so we run this process by clicking on the arrow button, and there we have our output. So there are various types of output over here. Now this output is the model itself. If you want to see the equation of the model, so you can click on the description tab over here, and you can see the model itself. It shows you the intercept. This is B0, the minus 15.38 is the B0. And then I forget exactly which variable was first. If I remember correctly, it was kilometers. So this minus 0.002 would be B1. Kilometers per liter, this 0.28 will be B2, followed by B3, followed by B4. So you can see those estimated values of the coefficients. Now let's get back to the other diagnostics in the regression output. Again, I will be brief here because the assumption is you're familiar with the conceptual foundations of multiple regression. So you have all these coefficients that you see over here, the minus 0.002, 0.28. These are sample coefficients. So these are proxies for the true coefficients since we don't have the population. These are simply sample data, so we always have to do a hypothesis test to check whether the true slope is different from zero. That's what these t-statistics give you. So just a quick sort of recap of what these numbers mean. This minus 1.66 means that the coefficient of kilometers, this minus 0.002, it looks like a small number, but what that means is that coefficient is 1.66 standard deviations away from zero. Okay, similarly, this 8.9 value that you're seeing for kilometers per liter tells you that the coefficient 0.28 is 8.9 standard deviations from zero. And the p-value values that you're seeing over here, these are the likelihood of a type 1 error. That is, what is the likelihood of you making your mistake if you conclude that the true slope is different from zero when in fact it is not. If in reality the true coefficient is zero and you say that the coefficient is different from zero, what is the likelihood that you made a mistake? Okay, so operationally you want p-values that are very, very low. And usually the thresholds, unless otherwise mentioned, the thresholds, common thresholds that are used are 1% and 5%. So if you get p-values that are less than 5%, that's a very common threshold that's used. Sometimes a threshold of 1% is used, but let's say for purpose of discussion, if you get a p-value that is less than 0.05, then you know that the coefficient is significant, meaning there is a high likelihood that the true slope is different from zero. So if you just look at this particular column for our example over here, you can see that the variable engine and the variable kilometers, they may not be entirely significant, meaning that their true slopes may not, you're not all that sure if those true slopes are different from zero. So they may not be contributing much to the prediction. So they are candidates for further simplifying the model. Now, in this tutorial, we will not discuss how to simplify a regression model or come up with, quote, an optimal model. We will have a different tutorial for that. All I'm showing you here is how to interpret the diagnostics that resulted from the training process. Okay, so now let's look at another result or output that we had requested in our design. We wanted to see the actual and the predicted values of the dependent variable. So you can see this in these two columns over here, the actual price and the predicted price. Okay, so the prediction was done using these 4 independent variables over here. Sometimes the prediction is higher than the actual, as you can see in the first row. Sometimes the prediction is lower than the actual, as you can see in the 4th row over here. Okay, that's what you would expect. Sometimes the prediction would be high, sometimes the prediction would be low. Okay, now let's look at the performance metrics that we had also requested. Remember, there was this operator called performance, and we had these 4 different metrics that we had asked for. So let's pick the one that should be most familiar to you, which is the R-squared value is 0.57. You know that the higher the R-squared, the better the fit in terms of training. The correlation is simply the square root of the R-squared value. So the root mean squared error, the average is 7.39, so the RMSE is 7.39. The average absolute error is 4.09. So these give you some estimate of the goodness of the fit. Okay, so these are performance metrics that were generated by as a result of the training process, and then when they're applied to the validation data, it gives you a sense of how good that the training was. So let's get back to the design over here. This is the process. So in this tutorial, I have shown you how to build a prediction model in RapidMiner using linear regression, multiple linear regression, when all the variables are quantitative. We've seen how to set up the data into training and validation subsets. And then once trained, we've seen how to judge the performance of the trained model. So this is sort of in a nutshell how you would use RapidMiner to build and evaluate a multiple linear regression prediction model. Thank you for listening. Thank you for your attention.